Ladies, thank you for joining in for this screencast. This is the second part of the 2.3b 2.4 notes that you received today in class. So we're looking at Roman numeral 2 and we are reviewing dividing polynomials. So let's first review long division with polynomials. I'd like you to divide 1 plus 3x squared plus x to the fourth by 3 minus 2x plus x squared. The first thing to remember with long division is that you should always put the polynomial in descending order according to the degree of each individual term. So we'll begin with x to the fourth. There is no x cubed term, so I'll put a place marker for it, plus 0x cubed plus 3x squared. There is no x to the fourth, so I'll put a place marker for that, plus 0x plus 1. And then on the outside, I do want to make sure that that polynomial is also in descending order. So x squared minus 2x plus 3. And we don't need a place marker as we have exponents of x to the second, x to the first, x to the 0. All right, let's get started dividing. I've often found that the most difficult part of this whole long division is for students to know where to begin. And you should always begin by dividing the first term on the inside by the first term on the outside. So you're dividing x to the fourth by x to the second. Remember, when you divide like bases, x and x are like bases, you subtract the exponent, so that's x squared. You should always remember to keep your like terms lined up vertically, so the x squared term will go over the 3x squared term. Remember, with long division, you divide, then multiply. We are multiplying x squared by x squared minus 2x plus 3, all three terms. So that's x to the fourth minus 2x cubed plus 3x squared. Remember, after you divide, multiply, then you will subtract. And when you subtract, remember, you are subtracting the entire polynomial. So you must distribute and make this plus a negative, plus a positive, and plus a negative. The first two terms will cancel. The second, 2x cubed. The last two terms will cancel, but I want to keep a place marker for x squared, so I'll put 0x squared. So we divide, multiply, subtract, and bring down. Okay, the next most difficult problem I recall students having is knowing what to do next. And again, you divide the first term on the inside by the first term on the outside. So that is 2x cubed divided by x squared. And that will reduce to 2x. So 2x is positive, so I'll put a plus 2x. Notice I still have all like terms lined up vertically. So I've now divided. Now we'll multiply. 2x times x squared is 2x cubed minus 4x squared plus 6x. So we have divided, we've multiplied, and now we will subtract. Remember, we're subtracting this entire polynomial, so we must distribute and make that plus a negative, plus a positive, plus a negative. These cancel, and we have 4x squared minus 6x, divide, multiply, subtract, bring down, plus 1. Okay, we're back to the division step. I'll now divide 4x squared by x squared, and that gives us 4. That's a positive 4, so I will add 4 on the end. After divide is multiply. 4 times x squared is 4x squared minus 8x plus 12. And now we'll subtract. Plus a negative, plus a positive, plus a negative. The first two terms cancel, and we have 2x minus 11. Now, remember, when you write your final answer in the standard form of a polynomial, you don't just write r for remainder. You have to write the remainder as a quotient because this is a quotient. We are dividing here. So our final answer is x squared plus 2x plus 4 plus 2x minus 11, there's our remainder, divided by x squared minus 2x plus 3. Okay, so there's a review of long division. If you'd like to stop now and practice long division again, I'm sure you could find an odd problem in your textbook or Google one to practice, so that will also have the answer with it. Let's look at synthetic division. When we divide synthetically, your binomial that you are dividing by must be in the form x minus c. And I should say 1x minus c. If x has a coefficient or a power greater than 1, you cannot use synthetic division. So in this case, what is c equal to? Did you say -2? Okay, so we put -2 in a little box to the left, and now we list the coefficients of the polynomial that's being divided. Again, in descending order. So x cubed's coefficient is 1. There is no x squared, so I'll put 0 as a place marker. The coefficient of x to the first is -7, and the coefficient of x to the 0 is -6. With synthetic division, we begin by bringing down the first term and multiplying. 1 times -2 is -2. Then we add 0 plus -2 is -2. Then multiply. -2 times -2 is 4. Then add. -7 plus 4 is -3. Multiply. -3 times 2 is +6. And -6 plus 6 is 0. Now, you don't just leave this with the coefficients. We have to put the coefficients back into polynomial form. Remember, this last term is your remainder. As we move from right to left, the first term, -3, is the coefficient of x to the 0. -2 is the coefficient of x to the first, and 1 is the coefficient of x squared. So our polynomial is x squared minus 2x minus 3. And I'd like you to notice something. If you go back up to number 1, we divided a polynomial of degree 4 by a polynomial of degree 2, and it reduced our quotient to a polynomial of degree 2. Remember, x to the 4th divided by x to the 2nd is x to the 2nd. Then, in example 2, we divided a polynomial of degree 3 by a polynomial of degree 1, and that reduced our polynomial to degree 2. X to the 3rd divided by x to the 1st is x squared. So I'm wanting you to see that when you divide polynomials, it reduces the degree of the quotient. Okay. I'm going to stop here and start a new recording for 3 and following. That way, if you want to take a break, you can.